Okay, I don't know exactly what happened at the end of the last part, but sorry if the result of that scalar multiplication was not obvious. So I think the last part of the video was kind of cut off, but what I was saying is that you can have scalar multiplication with addition and subtraction, such as a situation like this, where you gotta perform the multiplication first before subtraction. So just like an order of operation of regular numbers, multiplication and division comes first, and then addition and subtraction for matrices. Now, I would like to perform some multiplication of matrices. And multiplication of matrices has a rule. And that is, if I multiply a matrix, let's call it A, by matrix B, and let's say that the dimension of matrix A is m by n, that is m rows, n columns, and this one is A by B, let's say. A rows by A columns. In order for you to multiply these two matrices, the inner numbers of the dimensions have to be the same. If these two numbers are not the same, then the multiplication cannot proceed. And the resulting matrix, if these two are the same, once you do the multiplication, the resulting matrix has the dimensions that is defined by these numbers, the outer numbers. So let's go to page 582, and I want to multiply these two matrices given to me in example 6. Let's say matrix A, which is a square matrix, and matrix B, which is also a square matrix. So what's the dimension of matrix A? That's a 2 by 2. What's the dimension of matrix B? That's also a 2 by 2. Are these inner numbers the same? Yes. So I can multiply these two matrices, and the resulting matrix will also be a 2 by 2. So how do I multiply? A times B. That's how I show it. I write them next to each other. Like this. And what I do is basically some kind of it's a weird distribution. So basically I take this row of the first matrix and I multiply it by the first column of the second matrix. That means I distribute. So -2 times 4, 1 times 6. Imagine take this column that is like this and put it right next to this row that is horizontal, and put it right next to this column that is vertical, and then multiply the numbers and then add them. So you will get -2 times 4, which is 8, plus 1 times 6. So that's your first entry of the new matrix. And then you take this row and multiply it by this column, like this. So you get -2 times 3, which is 6, plus 1 times 1, which is 1. So we are done distributing this row. Then we do the same thing with this row. You take it and multiply by this. So 3 times 4 is 12, plus 4 times 6 is 24. And then this row times this column, 3 times 3 is 9, plus 4 times 1 is 4. So the resulting matrix will be 14, 36, 7, and 13. Is it 2 by 2? Yes, as we predicted, it's a 2 by 2 matrix. And that's the resulting matrix. All right. I think I made a mistake somewhere. Ooh, -2 times 4 is a -8. Boo-boo, boo-boo. -2 times 3 is a -6. That's a negative 5, and that's a negative 2. Sorry, negative 2 and negative 5 here. Yeah, I made a boo-boo. Okay, I forgot that was negative. Okay, but anyways. All right, so that's one example. Let's try. Now, the order, again, makes a difference. If I had B times A, then I would get a different result. Okay? So in multiplication of matrices, the order makes a difference. All right, let's try one more. This time, let's say if I want to multiply these two matrices, matrix A, which is the one that we had originally, and let's call the other one matrix E, which is a negative 2, negative 1, 3, 0, 1, 2. Okay, can I multiply A and E like this? Well, let's see. This is a 2 by 2. This is how many rows? That's 3 by 2. 3 rows, 2 columns. Are these two numbers the same? No, they're not. Therefore, I can't multiply these two matrices. Not possible. On the other hand, if I had E times A, now, what's the dimension of E? It's a 3 by 2. What's the dimension of A? It's a 2 by 2. Are the inner numbers the same? Yes, they are. So I can multiply E by A, and the resulting matrix will be a 3 by 2. So notice A times E was not possible, but E times A is possible. So let's try that. So we have negative 2, negative 1, 3, 0, 1, 2. That's matrix E times matrix A, negative 2, 1, 3, 4. So I can multiply these guys. So I'll take this row, multiply by this column. I want to make sure that I'm careful about my signs. So negative 2 times negative 2 is a 4. Negative 1 times 3 is a negative 3. And then this times the second column, negative 2 times 1 is a negative 2. Negative 1 times 4 is a negative 4. Then this row, 3 times negative 2 is negative 6. 0 times 3 is 0. 3 times 1 is 3. 0 times 4 is 0. Then this row times these two columns. 1 times negative 2 is negative 2. Plus 2 times 3 is 6. 1 times 1 is 1. 2 times 4 is 8. So my resulting matrix will be 1, negative 6, negative 6, 3, 4, 9. Perfecto. And I didn't make a mistake with the signs. Okay, so that's an example of multiplication of matrices, which, again, the order does make a difference. Okay, so I'm going to stop right there. I'm trying to make the videos a little shorter. I might have multiple parts, but make the videos a little shorter. See you in the next video.